welcome to Generative AI on Millions of Lines of Code. In this talk, I'm going to take you through our experiences at Modern on working with generative AI as a company that aims to make reliable code changes at scale. That might then seem like a contradiction to use AI, but we're going to look at how we have made that work. Now, I hope that you learn from our pragmatic approach of using generative AI to see how you too can leverage this new technology for your work. So first up, this is me. I'm Tim de Beek, and I'm a staff software engineer at Modern, where I'm the community lead for Open Rewrite. In this role, I help folks get more familiar with Open Rewrite and extending the recipe catalog that we have to their own needs. I also work on the tooling that we develop at Modern to aid developers, such as the CLI, the IntelliJ plugin, and the Modern platform. I'm a big fan of contributing to open source software, and once in a while you'll see me present at a conference like this one, just because I like to do so. But most importantly for this presentation is that this is not me. This is my brilliant colleague Justine, who has done all the hard work that goes into this presentation. She works from the Mila Institute in Montreal, and together with some other AI researchers there, she aims to bring groundbreaking AI research to Modern and to our customers. Now, Justine couldn't be here today. She's hard at work doing groundbreaking stuff, but so I get to travel in her place to very exotic locations like Veenendaal and Ede. So I'm happy to be here with you today. And she has been kind enough to help me through this presentation, but not least of which by writing a book on the subject, which is great if you want to build up a presentation to have a book to read and then give you a summary here. And if you want to get your hands on this book, then there will be a QR code near the end where you can get that exact PDF. Now, we both work at Modern, which, if you are unfamiliar, Modern is the main sponsor of Open Rewrite. Modern is a commercial platform that is designed to run Open Rewrite recipes at scale with incredible efficiency, supporting large code bases and multiple repositories. It's a place where platform teams can come together to collaborate and drive migrations across their code bases to mass commit fixes and perform large-scale analysis. We offer Modern for free to open source projects and to help maintain the projects that we have come to rely on. And beyond that, our customers use Modern to stay on top of upgrades, apply security fixes, and help maintain their code quality. Now, this is built on top of Open Rewrite. Open Rewrite is a safe refactoring framework, mostly written in Java, but it is usable across a range of different languages. It allows you to automate the boring parts of code maintenance, reducing technical debt and improving code quality and improving security. Folks tend to arrive at Open Rewrite when they do a Google search for how do I upgrade to the new Spring Boot version, how do I upgrade my Java version, and through that land on our docs where we help them automate those changes through open source software. Because Open Rewrite is Apache licensed, we have plugins available for Maven and Gradle to allow you to upgrade a single project at a time. You can go to our GitHub to see how it's implemented, and using parsers to build up and manipulate a model of your code. Now, Open Rewrite is also increasingly integrated into other tools, tools like IntelliJ IDE, where you have bundled support for Open Rewrite. And then there's offerings like Amazon Q, GitHub Copilot, Upgrade Assistant for Java, and Broadcom's Application Security Advisor. Now, all of those underneath use Open Rewrite. Now, if you had up to now never heard of Open Rewrite, then congrats, you already learned something useful today, but it's not going to be the focus of this presentation, because I've been doing these types of presentations for 3 years now, and we're going to talk about how at Modern we are using AI instead. If you want to learn more about this, there's going to be a bite-sized session in the afternoon, or you can watch any of the recordings that we have online as well. Now, when I talk about the safe code modifications that we can do, I'd like to use this brief example to show you what we're talking about. Because we're not talking about changing a dependency version only or changing some imports. We're actually making structural changes to the code that you have. And with this example, you can probably recognize that this is a JUnit 4 application that we're migrating to JUnit 5. And in the past, if you wanted to assert that a certain exception is thrown, you had to add an argument to the annotation. But if you move to JUnit 5, which came out 6 or 7 years ago, so we probably want to do that, you now have to instead call a different method, pass in the same argument, remove it from the annotation, then pass in a lambda to do this type of work. Now, I've spoken to quite a few folks who have done these types of migrations using regular expressions and saying that it mostly got the work done. Well, good luck with this one. You're not going to manage. This is just doesn't work very well. So we have a framework to allow these types of changes to be made. And then that is built on top of a very detailed model that we built up of your code. So on the left, you can see the model that we have, which contains extensive type information and information on how your project is formatted, such that we can make modifications to the code and write it back out again in a way that you recognize the code still, and then be upgraded to newer versions of JUnit, Java, Spring, or whatever library framework you might be using. Now, we use this to automate migrations across a range of languages and technologies such that you can, like I said, upgrade your applications, secure your applications, and improve the code quality. The Modern then runs these recipes at scale, both for the wider open source community and for our customers, such that if you have a couple of million lines of code to maintain, you can use this platform to make that maintenance very easy to do. It also means that there is a lot of trust involved. When we make code changes, things should just work. You don't want to make changes across a couple million lines of files and then have to review a couple million lines of files. So that way, things work well for our customers at that scale. Now, customers come to Modern to make it easier to manage their software. And while we have both small and large customers, typically you'll find that these are very large financial organizations. They have a ton of code. They've been programming Java for 20, sometimes 30 years. And they want to help improve the code quality of what they have. And these customers, they like predictability. They want accurate, repeatable code changes. And if you had a couple million lines of code to maintain, then probably you would want the same as well. Now, interestingly, we found that there is a split within our customers. They either love AI and want to help to use that to modernize their applications, or they have a severe distrust of AI and ask us to disable all AI features. So anytime we develop something new, we have to think about both of these types. You would either build it in, or you have an alternative that works without AI. So that makes for an interesting mix, and we've even had some customers who actually wanted Modern, but they only had budget for AI, so then we kind of have to inflate the AI capabilities while still remaining reliable in the code changes that we do. So with that context, we're now going to look at how we have been using generative AI to still help maintain your code in a way that remains predictable, and try to get value from a technology that is inherently unstable, and then make it such that our customers are getting the most out of that capability. And ideally, we want to keep the costs low, because we are a startup, and je blijft toch een Nederlander. You don't want to spend too much on the things that you're doing. So with that, I'm going to take you through our experiences at working with GenAI and how that has pretty much followed the hype cycle. You've likely seen this trend before, where for any new technology, at the early stages, things go wild a bit. There's an example at the top, blockchain for cat food. There is actually some folks who wrote a blog on proposing to use blockchain for cat food. And we see similar things now with AI. Probably someone very soon is going to write a blog on how you can improve cat food through AI. So while we've seen this before, there's also a trough of disillusionment, and then a slope of enlightenment, and a plateau of productivity. And we will take you through all of these stages that we went through. Because we started out with high expectations for AI. So when they first became available, we figured, well, this is going to be perfect. We had on or about 1,000 recipes back then. But there is a lot more ecosystem that we want to cover with our recipes. So we set out to use this new technology to help generate a new recipe to add to our catalog to expand what we can actually do for our users and our customers. Because previously, we've had folks be amazed that we can automate any part of their software maintenance at all. These days, we get complaints that we're not migrating their 10-year-old library that no one else is using, but they are using it, and we should be migrating it according to them, which is an interesting mix to now have. So then we set out to create our first AI recipe. You give it some prompts, it comes up with some code, and it looked quite convincing, especially to Justine, who at the time was rather new to the company. But then when she asked a colleague to review the recipe, we found some problems. The first most glaring problem was that it did not compile. And if you look even closer, you would find that it was using methods that just don't exist within the framework. Maybe they should exist, but it's kind of weird to get a suggestion or something to call a method, and it's just not there. And then the recipe also had no sense at all of using the visitor pattern to traverse the LST model that we have to modify your code. And in general, it was not an open rewrite recipe that it wrote. Because all of these confabulations, hallucinations, they're pretty hard to comment when you work with generative AI. So clearly, this was terrible. This was not going to work to fully generate a recipe. So it became time to scale back our expectations. So what we did is we drastically reduced the scope. And to do that, we tested it with a recipe that we actually have to fix a check style issue, where if you have a switch statement, as you can see on the left, the check style rule says that, well, you should put the default case last for readability to make it more predictable. And then as you do so, you also have to correctly account for fall through. You have to ideally not switch any of the other statements around. All of this, it is fairly easy to explain, but there's some finesse to it when it comes to automating this. So what I'll do is I'll take you through the recipe that we built to do exactly this with AI. Now, what you will notice here on line 58, this is the only instruction that we sent to OpenAPI in this case. All of the surrounding code is just to find a switch statement in your code, extract the switch statement only if we find a default case in that switch statement, and then send the whole thing off to our generative code editor with the instruction to write it again, but then with the default case last. I would absolutely love it if all my recipes were this easy to program. Just find the element, send it off, get it back correctly, and write it back into the code again. But then when it comes to running this, it is kind of interesting, because you kind of roll the dice and it works, or sometimes it doesn't work. Like the second time around, you might get slightly different result, which is kind of hard if you have an automation where we test all the changes that we make, where you have a defined input and you have a defined output, and you kind of want it to always produce the same result. But if you run this a couple hundred times, then you are in trouble, because you're going to get different results all over the place, and it's just not very good. So some of the failures that you see is that other case statements are reordered or failures not handled correctly. But maybe it's good to see this in a demo in IntelliJ. Because who here wants to see me gamble my career on running an OpenAI demo? Quite a few folks. Should be interesting, because if this actually works, then I am in big trouble. I'm not doing my job very well, and I'm not going to last very long. So let's see if this works. I'm going to switch screens to Mirror. Then I'm going to switch to IntelliJ. And what we have here is a unit test. So we have a unit test that runs our recipe with some plumbing in there. There's a token file that I'm not going to open today. And then here you have the input of our unit test, which says that we have a switch statement. You see on line 73, there is a default case. And we're going to send the whole thing off to OpenAI. And what I hope to get back is this altered switch statement with the default case now last. So we're going to run this once. We're going to roll the dice. We're going to see how we do. Now, there should be internet here, because we need that if you're sending things off to OpenAI. And when we send off our response, we expected a response within a couple seconds, because again, we're working at a very large scale. And then what we found is that it's not matching the actual result. So let's look at the differences. I try to open this up. And we find that on the left, you have the expected. On the right, we got what we actually have. And you see that it introduced some extra statements for case 2. So I think, well, it's not ideal. It's not exactly what I had hoped for. But let's change the test to actually make it so. So we add these 2 lines. We add it here. And then we're going to run it again and see if it actually matches. Because we got an output just right now, and let's run it again, see if it actually is green. And then already, I kind of want to see what it does when I run this 10 times, because once it's good, it's now green, it's doing what we hope. Let's see if it is stable. Because this is what we're going to do. We have folks that run our recipes, maybe on a daily schedule, maybe on every pull request, maybe every sprint. And you kind of want to have the same result each and every time. You definitely don't want to have those case statements be swapped around every couple of days again, because you're going to have to review all of these changes. Now, the tricky part here is that we're up to 6, and so far it's looking good. But every time I ran it up to now, you get these kind of failures. Now, I'm not doing anything here. You see my hands, there's no magic. But there is a failure here. It's actually doing something different in 10% of the cases. In this case, it's moved the case statement, or it's kept the case statement 2 in place and moved the one below and then do something else. And now I have something that I have to review. I've ran it 10 times, I get a different result, and then, yeah, it just isn't very stable. It's not looking too good to do this type of work. And then further down, we have another test that we like to write, where we say that in this case, we already have the default case as the end, and we would like it not to do anything at all. Now, I've made it a bit tricky, because you can see here that I also added a case named string default, just to see what the AI would do, because our instructions are very short. They just say, make the default case last. And let's run this 10 times as well and see what it does. Because ideally, it should be doing nothing at all. It's already done. But if we run this one, and we run it 10 times, I think we're going to see some interesting results. Because I've ran this demo before, and let's see what comes out the first one. So right off the bat, we see that we are making changes where we shouldn't be doing anything. It's already in the last place. Please don't touch my code. But the AI has thought, well, I can improve things still by adding some comments to it. I didn't ask for those. It's not doing very much. Why are you changing my code? And it's doing that. Is it very stable in doing that? Oh no, in this case, we actually got a response from our AI that we could not parse as a valid Java snippet. So that can happen as well. And then this is just looking at 2 different types of responses. Here there's a different comment being inserted. Clearly, just passing in one instruction to the OpenAI is not enough to get stable results out of the input here. So I'm going to switch back to join displays, and then to that one. And I think we see that my job for now, I think at least, is safe. So what can we do to make this better? Well, we can give better instructions. We gave a one-line statement saying just make the default case last. So we can be more specific. Don't change the order of any other statements. We can tell it to keep the logic exactly the same. Don't start to insert new code snippets. Don't add additional comments. But pretty soon you're going to find that natural language is not a perfect match to give instructions to AI. Perhaps there's a reason we've been using code to express the exact changes that you want to see happening. So I remember when I said that our customers would like things to just work, well, and that they like predictability in their results. We are, with our approach towards AI, now nearing the bottom of the trough of disillusionment. There's a lot of promise in the technology. You can send your code somewhere and get some code back. Sometimes it works. But it fails to materialize when you run this at scale. Because if you consider this, it's fine to use that AI assistant in your code, maybe get something back and then check it. But you're not going to do that for all your switch statements in a very large organization. Whereas you'd like to have those improvements applied once. So what can we do then with some AI? Let's start even smaller, something that is manageable, something that is unlikely to break anything. And that was this use case. Because we have interesting customers, and one of them is a French-Canadian bank. And as per the compliance with the local laws, they have to program in French. That means the comments have to be French. Even the Excel functions they call have to be French. It can't be a shortened English one. No, it has to be French. So to check their compliance with local laws, we wrote a model where we are able to extract the code comments that we find in our code, then analyze them through a sidecar where we've deployed a detection for the language, and then spit out a data table telling them how compliant they are with their local regulations. Now, this was already good enough for them, but it also helped solve a problem that they were having. Because this being a big bank with a lot of old software, they had undergone some iterations where over the years they changed the encoding of their files a couple times. And that is fine if you're just using plain old English, but if you have French accents in your comments, then suddenly you'll find that you get these weird characters once in a while, like question marks or UTF-byte characters. All of these mean that it's not very readable. And worse still, it meant that they could not generate their Java docs. So you have internal libraries and frameworks written in French, and as a developer, you want to know what is this function doing, but there's no help at all from your IDE because the Java doc can't compile with these silly characters in there. So what we did is we want to write a recipe that makes a diff and takes in those comments, tries to find any of those invalid characters and replaces them with the most likely replacement in French. So that's what we did through a sidecar model, and now we have something to not only fix those encodings issues, but also help improve the readability of the code and make it such that those libraries are now, again, showing up in your IDE with the Java comments that were intended. Now, if you want to learn more about this particular use case, then Justine has helpfully written a blog post. You can scan the QR code or get the slides later on, where you can see exactly how this did. We have our first use case using some AI as a sidecar to fix a problem that a customer was having. So we are slowly looking up at the slope of alignment. Now, next up, we had a use case where our search was pretty mediocre. We had about 1,000 recipes back then, it was proving troublesome to find a recipe that you were after. Now, being a Java shop where our first search was implemented with Lucene, and while it has some word stemming, it fails to be able to resolve any kind of synonyms that you might be using. So that meant that folks were just not finding the recipes that they were after. And then while we briefly considered upgrading to a better Lucene, it just wasn't going to fix the exact problem that we're having. So we skipped that option as well. So what we want to do now is to write a better search to help folks explore the recipes that we have and prevent a common problem we were starting to see, where folks would implement a recipe we already had because they just couldn't find it before. It's kind of silly. We have multiple cases of just, I can remove this one and rename it, and now you're done. So the first attempt that we had at running this, of course, early stages, was very naive. We took the query that the user had, I'm looking for a recipe to do such and such, and then we would add the description of the 1,000 recipes that we had, send it all off to OpenAI, and ask it to pick out the correct recipe to return. And this didn't work very well. The model just simply got confused by the size of the inputs. 1,000 descriptions meant that it lost track of what the query even was. So there was a lot of noise involved in the responses there. And it also started to invent recipes, which is very much not what you want. You start the search, you get a result, you think, oh, perfect. And then, it doesn't exist. Kind of frustrating. And then worse still, it was slow. It was taking like half a minute or a minute or something to just go through all those things where you want things to be snappy. You're searching for something. You don't want to lose your train of thought as you wait for these results to come in. So then for our second attempt, we went back to the documentation. We looked at retrieval augmented generation, which is becoming quite a bit more popular since then. And for this, you turn your search terms into a multidimensional float vector. It's exciting stuff. You have some query, you get out a number, and you can use that number to find things that are similar. Kind of feels like magic. But you're really looking for numbers that are close in space, but maybe not identical. Because what we wanted to do is also do that disambiguation, where you're searching for something and you want something to find close to it, but not exactly that, away from that keyword search that we had. And an example here is the two terms, love and hate. They might be very different in their meaning, but they're both passionate emotions. So they're going to cluster together in the same space, as opposed to a word like table, which is further removed from those two emotions. Now this approach in theory looked quite good, but in practice we had a test set of our own, like 20 queries that we wrote and the recipe we thought that would be best for this, and we got 1 out of every 20 correct. Now that is, again, pretty mediocre if you're doing a search. You want to find a recipe and you have like a 5% chance of finding the one that you're actually after. So this was the absolute low point in our AI research. We wanted to fully generate recipes and expand our catalog greatly, that whole hype peak that you had. But in reality, we couldn't even find the right recipe you're after, unless it was in 1 every 20 cases. So what Justine then did is that she went to her colleagues at Mila. Like I said, she works in Montreal. There's some 1,200 AI researchers all together. And she's she asked for help. I have a problem here. What can we do instead? And turns out you cannot use embeddings for search unless they are specifically trained for retrieval. So it's very good to have her there to be able to get this collective knowledge to be able to do the use cases that we have. So we set out to find a better model, some trained for retrieval, and with that, it is often overwhelming to find the right model for your task. But luckily, there is Hugging Face, which probably you've heard of at some point. It's a great place where they host a lot of models for you that you can directly use. And then they also have benchmark leaderboards where you can see which models might best fit a particular task. And the leaderboard that we went for was the massive text embedding benchmark to identify the characteristics of these models and how they perform on certain tasks. And these can be wildly different. There's some models on here which use dozens of gigabytes of memory to be able to do a search, and then they're outperformed by a model that uses just half a gig and works very well. So it's you want to test the models and how well they performed on your use case, and if you're able to make that work for your case in production as well, because who has a couple dozen gigs to run a quick search? So what we landed on is a model that's no longer in the top 10, but it works very well for our use case. And then our search is done now in 2 steps, where first we retrieve from that pre-filled vector database, as you can see in the top over here. And then we fill it with embeddings where each point in the embeddings is a particular recipe in the description that we have for that. Then when the user has a query, we use the distance between all those recipes and the query that the user has. And the most closely related top 25, they move on to the next step. Now, this is a re-ranking step where we filter out any maybe unrelated recipes that accidentally got picked up. And then that way we are able to narrow it down to the ones that are most likely to result in what the user is searching for. Now, the reason to have a 2-phase approach here is that threefold. So first, we can use a model that can use some cached factors, which you can't do if you have a very large model. But having 2 options here kind of makes us be able to narrow that down. And the smaller search space means for the second model match that you can use that larger one and not be overwhelmed with the response times that you get. You're also able to establish a threshold, only give me recipes above this certain score, to see if the recipe and the query are actually related. Now, as a very last step beyond this, we do a simple sort, where we want to have the recipes appear at the top, which have the most composite recipes within that. Because often when folks are looking for recipes, they are looking for maybe upgrading you to the latest version, not the latest version of Spring Boot. So we bubble these recipes to the top that actually have the most composite recipes in there. Now, if you want to learn more about this approach again, there's a blog post where you can see how all of this was done, where Justine goes into more detail about our choices of a model and also the deployment model that we are using. Now, in terms of cost efficiently, as I said before, we're trying to keep things down. We are actually using CPUs to run our models. We try to find a model that fits in memory and use CPU to search through it. And we leave the very expensive task of training those models on GPUs to others, which works quite well, I can see. Now I can do a brief demo of it where you can see the search that we have in practice on the recipe builder. So I'm going to switch screens again, and I'm going to mirror. And then jfall as well. Nope. And then we're trying to pull this one here. Nope. I'll do it this way. I'm going to take you to the recipe builder, which is something that you can use as well, because quite often we find that folks are searching for recipes because they want to compose their own recipes. Maybe you have a use case where you are building something on top of Spring Boot, and you want to migrate your own internal starter. So what we're going to do here is we're going to search for a recipe that allows you to rename a Maven dependency. And you can see that I can type very badly, but it's still going to find a close match because it adjusts for that where the keyword search would have me lost here. And we find a recipe, and I know for a fact that I'm looking for this one, which is actually not rename, but it's change Gradle or Maven dependency. So we pull it up, we give it some parameters. I want to upgrade some internal library that we have. And then you say update, and then it is part of your custom recipe. I should actually put something in here. Should be good. So now we have our first custom recipe. We found the recipe we were looking for through the rename Maven recipe. Now next up, I want to change a package as well. So it is actually a change Gradle Maven dependency. So I will do change package name, and I expect to find a recipe that is change package name. So now it's actually there, it's called rename package name. So this is where you can see that the consistency of how things are named isn't great. So we, again, give it some thing, and now we have a second recipe in the custom recipe that we have. This is going to be the start of how you compose your recipes for internal cases to be able to do exactly this. And through the search, I hope you saw that you get results quite quickly. The thing that you're looking for is usually at the top. And then the best thing is that you can also add existing recipes that we already have. So if you want to add your Spring Boot 3.x migration, then this is neatly sorted to the biggest recipes. We're going to add the one at the top. And now we have a custom recipe that will upgrade your internal starter. It will change the package that you have. And then it adds all the 2,600 recipes that we have for your Spring Boot migration. If you have a touchscreen, I can recommend that you can use it, and you can zoom things, and it's a lot of fun to play with. But this will actually do all the work that your application needs to upgrade to Spring Boot. And we can see that it's composed of various steps. We're first taking you to Spring Boot 2.7, which is this part of the branch, then take you to 3.0, and then from there, I'll apply all the changes to get you on Java 21 and all of that. Now we can run this very quickly, and you'll see some results start to pop up. And then I think we're going to upgrade some 190 projects, and we're already done with 22% of those. So this is the way you use the platform. You build your recipe, you run it quickly, you get that feedback, and then you use that to refine your recipe. You get a preview of those changes, and suddenly you're upgrading Spring Guides, REST HTOS projects to a newer Java version and Spring Boot version, and you see all those changes being made. So this is how you run the recipe builder, use the search, AI-powered to be able to do these use cases. So with that, let's switch back to the presentation. I'm going to join this place again. I'm going to try to find that tab. Near perfect? No? Okay. Going. No. Come on. Okay. Try it again. This is always why you should be paying some money for the operating system that you're using, which I'm not doing. I'm going to try the mirror. This one's good. Presenter view. And it's not doing it. Oh, come on. Join. Looking good. All back. So, search is good, search is nice, but it's not really what we want. Because we have 2,900 recipes by now, we would much rather give you recommendations. Rather than have you learn all the 2,900 things that we can do, we would love to just give us your code, and we will give you the recommendations of the things you should be running to help improve your code. So that's what we worked on next, recommendations. We have a building block that allows you to search for recipes. Now we're going to use Gen AI to actually try to give improvements for the code that you have. So what we came up with is a simple prompt where we take a snippet of your code, as you saw me do with the switch statement, so we can do that with a method declaration, for instance, and then you send it off to Gen AI, and you say, well, you are a software engineer, what can you do to improve this code for me? And then it comes back with some suggestions, which is pretty decent. It'll give you a couple of suggestions. But we found a very clear way to get better suggestions on the code that it can improve. And that is to fake it until you make it by adding senior to your title. If you are a senior software developer, suddenly you get a lot better recommendations about what can be improved by your code. So it's just, you play around with it, this works, and then, yeah. And then what you get is you take an input. You take a method declaration that you have, all the body in there, there's maybe some Java docs and things, and then you feed it to the LLM. And you tell it again that you are a senior software development, give me some recommendations, how can I improve this beautiful getter that I have? And then it comes back with a brilliant description. Well, you should upgrade to Java 8 or later, because the Boolean class was introduced in Java 5, and it has been deprecated in the... That is a load of bollocks. That is just not true. But the nice thing is, if you have a search which works on embeddings, actually it clusters together quite well with our Java upgrade recipe. So the input here can be clearly wrong, but as long as it is on the theme of what you're searching for, it doesn't really matter. So that is what we're striving for. We're using Gen AI, and then send this off and get a description, use the search, and get something back that is closely related to what we want, and then you have a recipe to make the reliable code changes. So that looks good. But then there's the problem of scale, because for our customers, typically they are working on a large scale where they might have some 1,200 repositories, as we have here in our public tenant for Netflix, Spring, and Apache. They have some 62 million lines of code, sounds about right for what we work with. And then we're going to send every method declaration that we have off to our AI to get an improvement, so some recommendations on doing exactly that. So in that 60 million lines of code, we found some 400,000 method declarations. It takes us about 3 seconds to get a recommendation back from AI. In total, if you send that query off, that would take 2 weeks, which is not great if you have an AI and you press a button and then come back in 2 weeks, we'll have an answer for you with some recommendations, recipes to run to actually get something meaningful back. And then we're still, of those 400,000, there's going to be a ton of getters that is going to send off and then give you recommendations on getters. It's not very great. And if you were to do some massive work to half the time here, you'll have 1 week to get your answers. It's just not very easy to work on a large scale. So what we want to do is we want to do some way to limit the search space by using embeddings. In this case, what we're going to do is we take all those method declarations of method invocations in that sample that we have, and then we want to try to find cluster those in a way that we can do some sampling. Because what we kind of want to see is that if you have sampling of all those methods, and then you pick some representatives from each cluster, and then you run the recommendations, that you probably get some recommendations that apply to all of the red circle, all of the green circle. And that is a very neat way to be able to make this a manageable problem. So in this case, like I said, you just pull out one of them, and then that one will be representative, get a recipe recommendation in a reasonable amount of time. So we ended up with this workflow. You have on the top left, you have the inputs, the lossless semantic tree. You throw it all in there, and then you cluster the methods that we have there, and then you do that diverse sampling. And using these sampled method definitions, we generate those modernization recommendations, and then, like I said, it was on the theme of your senior software development. Give me 3 things that you can improve, and then you get back a list of recipes to run. Now, it doesn't really matter, like I said, if the suggestions are completely wrong, as long as they cluster together nicely. We have that recipe catalog to filter out any problems that we have, to actually give you meaningful recommendations on recipes that you can run for your code. And of course, as a next step, we're looking to add that into a dashboard where you just every week get a recommendation, like you've done this last week, and now our new suggestions are to run these recipes on your source code to continuously improve things without having to learn 2,900 individual recipes. Now, if you want to learn more about that, then again, Justine has you covered. So where you can see just how we use this, and I could go into a demo of this, but in terms of time, I'm going to keep it a bit shorter. So it's working quite well. And then the next thing that we wanted to do is the most groundbreaking work that we've done so far with AI, and that is on code search, which, again, came from a customer use case. They always have the best problems that we get to solve. Use some research and methods to be able to fix that. And one of them was that they are using a particular vendor for their identity access management. And that vendor wanted to raise their prices 3-fold within 3 months, which the vendor, of course, knows is you're not going to easily move away from us. So we have you. We're going to just triple the price, and you're going to just have to stick with it. But our customer kind of wanted to not do that. They wanted to switch to a different vendor. But this was, of course, identity access management, so it's integrated all over the place, and they didn't even know all the different ways that they had integrated with that vendor. But as it turned out, all of the usages of the API of the vendor were all passing in a particular HTTP method. Now, we have in our platform already a recipe where you can find that I am using this particular web client and this particular method. Give me all the usages. We can tell you that if you know which client you're using. But this was a very large customer, and they didn't even know all the different HTTP clients that they have. So instead, we had to help them find and discover all the ways that they are using that particular HTTP header in their HTTP clients. So what we did is we helped them write a natural language query, as you could see on the previous slide, find all HTTP requests that set the authorization header. But then we came to the next problem, because this is now looking at search across the entire organization. We can't do the sampling that we did previously to speed things up. Because if you're going to sample, you're going to find things in your sample. This can not work very well. So the solution then was to use an embedding model to find which method invocations are actually mapped to the same query. So we did, like I said, we can't sample very much. So what we did here is we look across all method invocations. We get the definition for all of those method invocations, the signature of the method. And then from those, we're going to look at the top, say, 500 of all the unique method signatures to see if they match, are you an HTTP request sending method potentially. And then we go through all those 400,000 method invocations again to see if they are one of the top 500 methods we identified as a likely candidate, and then verify if they actually match the user query in their particular use there. Are you sending that exact header that we're looking at, as opposed to what we did? So this is the pipeline. And the pipeline on the left, again, we start with the lossless semantic tree. You have that first scan to get out all the method signatures. You have an embedding model to see if they are close to what the query of setting a particular HTTP header. And then we take the top 500, like I said. And then next up, once we have that top 500, and we are actually looking at individual method invocations, then we have a series of models to say if this is what we're looking for. And that series of model is to make it manageable with the search space that we have. So on the left, we have a very small model, which gives you a clear yes, this is what we're looking for, or a clear no, this is not what we're looking for. Or it says, I don't know. And if we don't know, then we move on to the next model, which is slightly more advanced. It needs more to be able to do that type of classification. But again, it is able to give a clear yes, a clear no, or I don't know. And then finally, you end up at the third model. And if that one has a probability of saying yes as the first word of what it says, is this related or not, then we decide that it is something to be included. And that then becomes everything that's filtered out through yes is the search results that we end up with. So what we ended up is that we were able to find all the different libraries that they were using to set a particular HTTP header. A couple of them they knew about, a couple of them were new to the folks doing that research, but we were able to find all of them and help them then next target those same methods to transform it and use the different vendor and get out of that troublesome contract that they had. So again, if you want to read more about that, we have a blog to wrap all of that up. And then you can see what went into making that exact use case work. So to wrap up, let's look over what we have done and what you could similarly use as patterns as you start to adopt generative AI within your own use cases. You've seen us use the AI-powered search at the top left, where we are now able to look across use your query and those embeddings to find recipes that cluster together nicely, and then give you a top 20 or so results of what you the recipe that you're actually looking for, and use that in our builder and our other use cases within the platform as a building block that helps us offer something useful through AI. Then next up, we have that second use case where you're now able to use that recommendations. Get a generative AI mediocre description of what it thinks it can improve about your code, but then feed it into our search, which is nicely safeguarded, to be able to give you a clear improvement that you can run in a reliable way. And then finally, we have that code search if you want to do more and be able to find things that you didn't know match your query to be able to target those then next for reliable automations. So with that, we have found a good way for us to use generative AI for a number of different use cases where the AI itself is unreliable. It's not stable in what it produces. It's going to give you maybe a wrong answer, but still have a way to give predictable results when it comes to those automated code changes that we're after. Now, a couple quick takeaways from Justine on her recommendations on what to use if you want to start out for yourself. And the first use case really is that it is pretty hard to scale up AI. You might have a convincing demo on a small project on your laptop or something small, but if you take that to a large scale, it's just not very easy. So you need to find something to rein in the generative element of the AI. For us, that is by not using the AI to do the code changes. As you saw in the demo, you get a different result every time you run it. Throw the dice, you just don't know. But having a recipe catalog and using that to make the actual code changes works very well for us, and try to find a similar way to do that for your own code. You also want to integrate in two parts. First, you want to test your research methods, like Justine did with her colleagues at the Mila Institute. Be sure that you're using models in the right way. Is it the right model for the right task? Are you using the right embeddings and everything? That should be part of making sure that you're actually building something that is going to work. And she also recommends that you deploy very easy, because it's well enough to have a demo that works on your machine if only you have this exact version of Python, those 27 packages, and this exact multi-gigabyte model. If you can't run it in production, it's not going to work very well. So her recommendation is to immediately deploy something that just returns a stable answer, yes. And if you're able to run that as a Python script in production from your the Java code, then you have something that might actually work. And then finally, training is very hard. It is very expensive. She recommends to reuse existing models that you get from Hugging Face or a different platform that hosts these for you to be able to do exactly that. And then run it in a cheap way if you can. But in our case, we couldn't use OpenAI because our customers just would not accept that. So we have to run things internally, which is slightly more difficult. So with that, we're near the end. If you want to learn more about any of this, these are the links that you can go to learn more about how we have built all of this, particularly on our blog. If you want to read the book that Justine has written, then there's a QR code on the right. And then with that, I want to thank you all for your attention.